This video is to demonstrate factoring a perfect square trinomial, and what we have here are the formulas that we'll be using for this. So on the left side you see the trinomial that happens to be in the perfect square form, and on the right side you'll see the factored form of that trinomial. So these are very similar. The only difference is, of course, you could have a negative sign between the first two terms, and that would mean that the factored form has a negative sign as well. So we're going to start with an example that is 16x squared minus 24x plus 9. Now, if you're given a trinomial, of course check to see if there's a greatest common factor to pull out. In this case there is not. Then the next thing to check is, as you can see in these formulas, the first and third terms are both something squared, or perfect squares, and so that's the first thing to check. If you can see that the first and last terms, and we're using descending order of powers here, are indeed perfect squares, then there's a good chance, not a guarantee, that it could match up to one of these formulas. Now obviously we have a negative sign between the first two terms, and so it might match this form if anything. So the first step is to write the first and third terms as something squared. So in this case 4x squared would be 16x squared, and 3 squared would give us the 9. Then you have to test the middle term to make sure it matches this middle term in the formula. So in other words, I'm expecting this to be minus 2ab, just like the formula, if it's a match. And factoring the first and third terms, or rather writing them as something squared, will show you what a and b are supposed to be if it is a match. So in other words, 4x would be a and 3 would be b. So I'm going to take those a and b values and now plug them in here as 4x and 3. And if with this 2, which comes from the formula, this term matches the original middle term, then this whole thing is a match to a perfect square. And as you can see, negative 2 times 4 times 3 is indeed negative 24, and so this does match completely the perfect square trinomial form. Well, as soon as you verify that it's a match, and in that process you've identified a and b, the last result is, or final step, is to just write it in factored form, which is a minus b all squared. Okay, well we already said that a was 4x minus, and then b is 3 squared, and now we're done. So let's do another example. This time I'll show it with larger numbers, and this is where this formula really comes in handy, because in fact a problem like this could be done, maybe not easily, but with a different method of factoring of trinomials. This next example would be quite difficult to do with other examples, or at least more time consuming. And so here it is. And again, our only hope of this being a perfect square is first that the ends, the first and last terms, when written in descending order, are perfect squares. And as you can tell, we can write this as 12x squared and 13 squared is 169. Now we just have to check the middle term to see if it matches the 2ab. So in this case we're using the positive form, which is the first one. So I'm going to write 2 plus 2 and then 2 parentheses. I should be able to plug what I now know as a, right here, and this as b, into these 2 parentheses, so 12x and 13, and when multiplied by 2, again the 2 coming from the formula up here, this should match this middle term. If it does, then this whole thing does match as a perfect square. Okay, well, you can check 12 times 13 times 2 is indeed 312. So this is a match, meaning my final factored form is simply a. In this case, plus, it always matches the first sign, and then b, 13 squared. So there's another factored perfect square trinomial using the formula. Now I want to show you an example that doesn't actually work, though at first glance may seem like it does. And that example would be this. Let's say we had 6x plus 4 plus 9x squared. Now, regardless of whether this is a perfect square or not, you would want to rewrite it in descending order of powers. So I'm going to write the 9x squared term first, then the plus 6x, and then the plus 4, just so we get descending order. And then you can look at the outer terms, the first and the third, and as you can tell, they are perfect squares. I can write this as 3x squared and this as 2 squared. But now if I go to check the middle term, it's supposed to be 2ab, where a is 3x and b is 2. But when I plug in 3x and 2, this, when multiplied together, does not equal 6x. In fact, it equals 12x. So because of this, not a match to the original term. Therefore, this is not a perfect square. Trinomial. Now, it may be factorable in another way or not, but all we know at this point is that it is not a perfect square. So there are some examples of factoring a perfect square trinomial.